Hello, Algebra 2. So today we are going to be looking at writing the equation of a line, whether you're given it as a description or from data or from 2 points. So the different points, different ways you can write the equation of a line. So first we need to review the equation of a line. So the first way, which you probably all is the one everyone seems to remember, slope-intercept form. That one is the one y equals mx plus b, where m, of course, is your slope, and b is the y-intercept. Then the other one, which people don't seem to use as much, but actually is way easier, is called point-slope form. Point-slope means you can just take a point and the slope, you plug it in and you don't have to solve for anything or simplify anything. So m is still your slope, but now you have a particular point, x1, y1. And so we also want to review, how do you even find slope? Yes, we know it's rise over run. That means you take the difference of your y values over the difference in your x values. All right, so let's get to it. So down here, we have a grid with 2 dots already on it, so we want to come up with the equation of a line in both forms. And so in order to do that, we need to know what these points are. So this one is at -4, +1. The second point is 4 over, up 5. So you do the x, then the y. So in both cases, we're going to need to find the slope. So one thing I recommend is that you put the 2 coordinates on top of each other, so 4, 5, -4, 1, and then I do this because people often, even in calculus, still do run over rise. So now we do the difference. 5 minus 1 is going to be 4. 4 minus, so remember you're subtracting these two, so 4 minus a -4 is going to be 8. And that is going to simplify to 1/2. So there is our slope. So the slope is going to be 1/2. Now the nice thing about point slope is you choose a point, either one. I'm going to choose 4, 5 because it has no negatives in it. And we just basically, it's almost like a template. You plug it into the equation. So we're doing point slope, so that's going to be y minus the y value, which is 5. Equals your slope, then x minus the x value of that point, and you're done. Slope-intercept form is a little more complicated, even though everyone seems to like it more, because we do have the slope, but we don't have b, so we have to solve for b. Now there's 2 ways you can do that. You can, if you've done point slope first, you can then just distribute and isolate y. So maybe I'll do both ways just so you see them both. So we could take what we have from above and go y equals 5, I'm adding 5 to this side, plus 1/2 x minus, so I'm distributing the 1/2, so half of 4 is going to be 2, and then simplify that. Y equals 1/2 x, 5 minus 2 is a +3. Now, if you didn't do it that way, if you did it straight from the 2 points, what you would have to do is you would have to take one of the xy values. Again, I'm going to use 4, 5, and our slope is 1/2, and I'm going to plug in. So y equals 1/2 the x value plus b. So 5 equals 2 plus b, so we find out that b is 3, and then you put it all together, and you get the same thing we have over here. All right, so either way, I don't really care which way you use, whatever speaks to you. So down here, we're actually given a graph of a line and 2 different situations, and we want to find the equation of the line, and we also want to interpret what does the equation of a line represent? What does the slope represent? What does the y-intercept represent? So the first thing we're going to do is find the slope of this first one. So we're going to do rise over run. So 51 minus 50 over 10 minus 0. And that is going to give us a slope of 1/10. And notice we got lucky here. Anytime you are given a x coordinate is 0, that means you have, this is your b value. So we know that y equals 1/10 x plus 50. And so now, they want us to determine the meaning of the slope and the y-intercept. So let's look at what they told us. In the x direction, we have the number of text messages sent, and then the cost. So the slope represents the number of text messages, and so we have here the cost per text message, since it's rise over run. So the cost per every text message. What does the y-intercept mean? Well, notice you haven't sent any text messages, but you're still being charged $50. So that's like the initial fee just for having the service. Okay, I realize most of you nowadays have unlimited, but that's how it would work otherwise. All right, this other one is comparing your math grade, so the homework grade to the number of completed assignments. And we don't have the direct y-intercept, so we have to go through first and find our slope. So 95 minus 85 over 20 minus 10. So my slope is going to be 10 over 10, which equals 1. That was very convenient. And so then we're going to do point slope for this one. So we have y minus, just choose either point. I'm going to choose this one, 85 equals 1. Don't really need that. X minus 10. So y equals x. I'm going to add 85, so this will be x plus 75. Sorry, I hit the wrong button there. So here's our equation. So what does this mean? Well, this means that your homework grade is going to go up. Since this is a percentage, it goes up 1% for every assignment completed. Ha, wouldn't that be nice? So what does your slope mean? Your grade improves, because it's a positive slope, 1% per completed grade assignment. Completed assignment. Now this one, the y-intercept doesn't really make sense because you're not going to get a 75% grade with 0 completed assignments. Sometimes that just is how that particular equation works. They're starting you at 75, but that's actually doesn't even make sense. So we're going to go on to example 3. It has here the cost of parking in a parking garage in Chicago is represented by this equation, 15x plus 20, where y is the cost in dollars, x is the time, because they're gonna give you a flat fee just for parking there and then charge you a little bit extra every hour that you're there. And then if you were to park in Denver, that information is based on this table. So they want to know which city's parking garage charges more per hour and by how much more. So we know that Chicago is charging, the per hour is going to be your slope. So Chicago is being charged $15 per hour. Denver, on the other hand, we're going to have to calculate. So Denver, let's see, we'll go 51 minus 43 over 3 minus 2. And so that is going to give us $8 per hour. Okay, so Chicago is more expensive on the hourly rate by $7. So Chicago is $7 more per hour than Denver. Kind of makes sense, a bigger city, although Denver's not a small city either. Let's see. After how many hours would parking in both cities cost the same? So in order to do that, we want to set both equations equal. When does the one equation equal the other equation? But for Denver, we don't actually have the full equation. We only have its slope. So let's go back and do Denver's equation. So at this point, I'm going to use the point slope form. So y minus 43 equals 8, x minus 2, and then solve for y. So y equals 8x minus 16 plus 43. So Denver's full equation is going to be, this will then be plus 27. So here's Denver's equation. And then we had Chicago. So we set them equal to each other. 15x plus 20 equals 8x plus 27. And we solve. So subtract 8x from both sides. Subtract 20 from both sides. Wow, look at that. After, whoops, I shouldn't have done that, sorry. This should be after 1 hour, because that's what x represents. Parking costs are the same in both cities are equal. Okay? So we've looked at writing the equation of a line given 2 points or given a situation and finding when the two equations might be equal. Now we're going to be given some data in a table, which is really more how life works. Life doesn't hand you an equation. Life hands you data, and then you have to do something with it. You have to find the pattern. So we want to see if we can discover when the given data is linear versus not linear. So the way we do that is we look at the change in the x's. So notice up here in this example, you keep going up by 1, up by 1. This is called a constant rate of change. And in the y values, you want the same thing. So 8, what we're really doing here is 8 minus 11. That's a negative 3. 5 minus 8, negative 3. So the first difference that we take results in a constant rate of change. And that is what tells us that this is a linear function. Okay, so here we're given some data in a table, and we want to discover if there is a constant rate of change. And it has to go between remember, the slope is the change in the y. This is how we write it, delta y over delta x. That's how you're looking for that constant rate of change, even if things are not always consistent on top. So for instance, we have here 3 minus 1 plus 2, plus 2, plus 3, which is okay if we have a similar change in the bottom. This is plus 2. Now let's look at what's going on here. This is plus 4, so I have 4 over 2, which is a slope. This one is plus 3, 3 over 2. So since 4 over 2, rise over run, does not equal 3 over 2, that is not linear. Okay, let's look at this next one. We have plus 1, plus 1, plus 2, which might be okay if the ratio of rise over run is the same. Here's plus 2. This is plus 3, plus 3, plus 6, plus 6. So notice 3 over 1 does equal 6 over 2 because that reduces. So that is our constant rate of change, which is our slope. So this is, in fact, a linear equation. All right, let's try this third one. So we see we have plus 1, and then we have plus 1, plus 2, plus 4. And again, it's about the ratio of rise over run. So this one is plus 2. So we want all our ratios to reduce to 2 over 1. Now this one, 4 plus 5 is plus 1, so that, since 2 over 1 does not equal 1 over 1, this is not going to be linear. Okay? Now, for the table that represents a linear relationship, which was B, write the equation of the line represented by the data. Well, the nice thing is we already know our slope. It's going to be, sorry, 3 over 1, which is 3. And so what I can do is I'm going to use 2 points. So y minus the y value equals my slope, x minus the x value. And you know what? Does it say, if it doesn't say what relationship to put it into, as far as I'm concerned, point slope is way easier because you're done to walk away. Use the equation in the line to estimate y when x equals 20. Well, now here we might want to move things around, so maybe I will go ahead. Y equals 3x minus 3 plus 4. So we know that gives us y equals 3x plus 1. So we're going to plug in when x is 20, because now we can use our equation to predict down the road for the data we don't have, so 60 plus 1. So that, when you're moving beyond the given data to try and make a prediction based on the given data, that's called extrapolation. You don't necessarily have to know that word, I just threw that out there. Okay, so I hope this was all good.